1 over
Thank you, thank you, thank you. 1 over x squared plus x plus 3 and
times the inner prime.
very good. 2x plus 1. Brilliant. Yes, thank you, thank you, thank you. Okay. F prime of x, source number 1, equals 0. Source number 2, f prime of x being undefined. This will be undefined when x squared plus x plus 3 is 0. Never. So no critical numbers come from f prime being undefined. When is a fraction 0? Because I have to solve this equation. So when is this fraction equal to 0? Only when the what?
When the denominator goes to 0?
Never. That would be a huge problem. Never.
Less than equal to?
So let's talk about this. This is very important. That's okay. It's okay. A divided by B. That's not possible. How do I stop that? So my apologies for that. So A over B is 0 only if A is 0. A over B is undefined only if B is 0. Please always remember this. Do not touch the denominator ever. There is nothing to say about the denominator of a rational function, other than if it's 0, we are in trouble. So a fraction is 0 only if the top is 0. If the bottom is 0, the function does not exist. We have nothing to talk about. So coming back here, when is this fraction 0? What should I write?
2x plus 1 equals 0.
Very good, which means x equals -1/2. And this is the only critical number. So -1/2, 0. At this point, I have to plug in -1/2 in the function. You know exactly what I'm going to do. I'm going to put the function in. Okay, here's the function. Natural log of x squared plus x and then plus 3. And then all I want to plug in is -0.5. Give me the answer. And the answer is 1.01. Perfect. So let's recap. I have the function. I have the domain. I get my table going. Make it as wide as possible because we may have to insert things. Who knows? Later on, you'll see what happens. So now I have the critical number. I solve the equation, a fraction equals 0 only when the top is 0. I got the critical number. I put it in the table where it belongs. I put 0 under f prime. I could have put undefined, but that's not from undefined source. Okay, I have the point. Now I have to study the sign of the derivative left and right. If this is positive and this is negative, then this is a relative max. If this is negative and this is positive, then this is a relative min. Now, before we look at that, this situation, positive, 0, undefined, positive, or negative, 0, undefined, negative for the derivative, nothing, neither max nor min. If there is no sign change in the derivative, left and right of the critical number, like here, there is no sign change. There is no max or min. So this is the critical number coming from f prime being 0 or f prime being undefined. If there is no sign change of the derivative, this is not a relative max. If there is no sign change, it's negative, negative, there is no relative minimum, nothing. So coming back here, I have to study the sign of this function. I am not going to study the sign of the derivative, of the denominator. No, 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 I'm not going to waste my time. I know it's always positive. I'm not going to look at this. It will be a waste of time. I'm only going to look at the numerator. Only the numerator will give the sign of the first derivative. If I put in 0, I get positive. If I put in negative 10, I get negative, which clearly indicates this. What type of point is negative 1/2, comma, 1.01 for this function?
Relative minimum.
Thank you. Very good pick. We needed to see as many functions as possible. Any questions, please? Don't let me ask questions. Please ask.
When you first were finding the domain,
Yes.
how did you figure out it was all real numbers from your calculator?
Excellent question. Very good question.
Is this all still 3.1?
Everything so far is 3.1, yes.
Okay, thank you.
Thank you. Quadratic functions. F of x equals ax squared plus bx plus c. If a is positive, the function has a minimum. If a is negative, the function has a maximum. In our case, the function was x squared plus x plus 3. It has a leading coefficient that is positive. So it looks like this. And it has no x-intercepts. Very good question. Thank you, Kylie. Thank you. Very good question. So this is a quadratic function. It does not touch the x-axis because there are no x-intercepts. It does not touch the x-axis, and it has a leading coefficient that is positive. So it has to have a minimum. It has a minimum, but it does not touch the x-axis, which means it's always forever positive. Very good question. Thank you. Another option, which I don't really like, but another option is to put the function in the graphing calculator and use the standard, and you will see. It has a positive leading coefficient. It never touches the x-axis, and it has a minimum. So it has to be way up there. Very good. Okay. Any other questions? Okay. Let's take a look at a word problem. Let's see what we want to look at. We want to look at the solar eclipse. Yes? No?
this one.
Okay, so let's see what they want. We're given f of t, so this is 71. F of t equals 0.00259 t squared minus 0.457 t plus 36.237. Okay, and they're asking us, so latitude in degrees south of the equator and t minutes after the start of the total eclipse. What is the latitude closest to the equator in degrees at which the total eclipse was visible? So obviously this is a quadratic function. That's one of the reasons why I looked at it, because we just talked about it. And it has a minimum because the leading coefficient is positive. So they really want us to determine the closest. So they want us to find the minimum. You can say, I know from algebra how to find the minimum. Yes, but we are in calculus, so we are using a different method. So first I have to find the critical number. So in other words, the problem is asking us, find the extrema, in this case, the minimum. I have to find f prime of t. So this is ugly. So 1 and 1, 4, 5, 0, 0, t minus 0.457. There is nothing undefined here, so f prime of t is not undefined, but f prime of t can be 0, which means t equals 0.457 over 0.00518. So let's see what that is. What is 0.457 divided by 0.00518? So 88.22. And that is, okay, t in minutes. So we haven't found the minimum. So next step. Since t is in minutes, there is no point in writing anything else as the domain. You can say, but it's a quadratic. Domain of the quadratic is negative infinity to infinity, right? But when we talk about minutes, that's all I can use, 0 to infinity. So this is 88.22. The first derivative is 0, as we know. We have to find the value. Of course, you know what I'm going to do. I'm going to create the function, put the function in, clear, 0.00259 t squared. Oh, okay, you should take it. Okay, minus 0.457 t and plus 36.237, and all I want to plug in is 88.22. Okay, 16.1. I know that this has to be a minimum, but I need to study the sign of the derivative. This is what we learned here in calculus. So when I plug in 0, obviously it's negative. When I plug in a million, obviously it will be positive. So this is a typical situation as expected. So what is this point for that function? What is this point? Very good. As we expected, we knew that from the very beginning. Okay. I know I have 10 minutes left. Okay. I would like to start section 3.2. So as you notice so far in section 3.1, our discussion revolved around the first derivative. The first derivative is the key here for critical numbers, for max min, for everything. That's what we discussed. I would like now to discuss the second derivative. And no, we're not going to go beyond the second derivative, I promise. So that's my page 9, I think. This is 3.2. Second derivative. Again, I'd like to recap. F prime of x gives max min. I mean, this is not the perfect order. Critical numbers. Critical numbers should be first max min. Increasing, decreasing intervals. So the first derivative is the culprit, so to speak, for 3 different things. Critical numbers that may change into max min, and increasing, decreasing intervals. This information about the function, all these pieces come from the first derivative. The first derivative gives us critical numbers, max min, and increasing and decreasing intervals. Okay, so what's the deal with the second derivative? The second derivative gives concavity. What does this mean? If the function holds water, concave upward, and concave downward. 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 Upward, downward. Concavity. The second very important element is point or points of inflection. Concavity, holding water or not, upward, downward, and points of inflection. What is a point of inflection? This is a point of inflection point, where the function changes concavity from opening upward to opening downward, or vice versa, from opening downward to opening upward. These are the points of inflection. So the second derivative, concavity, and points of inflection. So I would like us, we still have a minute. Yes, we have 6 minutes. So I would like us to simply just do that. Just find concavity and points of inflection. Okay, moving on to page 290. Actually, 291. Okay, so I would like to choose a problem. Like, let's say 13, and see what we can do with it. That's page 10 and 13, and this is on page 291, and that is h of x equals x to the third minus 27x. Okay. Good. So I would like us to study a max min and points of inflection. Of course, So the function is defined everywhere. It's a polynomial function, friendly, no problem. F prime, the function, and the second derivative. Okay. So first I'll find the first derivative. I can never find the second derivative before I find the first anyway. F prime of x, it's 3x squared minus 27. Of course, I will factor out a 3 and I have x squared minus 9. And can anyone factor out for us x squared minus 9? Completely factor x squared minus 9.
X plus 3x minus 3.
Thank you very much. Nothing is undefined, so f prime of x equals 0 has two solutions. I have to put them in the table. And what are they?
3 and negative 3.
Thank you very much. In the correct order, be very careful. 0 for the 0 for the derivative, and now we have to determine the function values at that point, those points, at those values. I was just getting ready to say, careful where you put it, and I jumped ahead. I didn't even listen to my own advice. Okay, so in y equals, I have the function that is x to the third. Now, of course, x to the third minus 27x. And what I want is negative 3 and positive 3. So 54 and negative 54. 54 and negative 54. Perfect. Now I will study the sign of the first derivative. This is the first derivative. Negative 10. Negative, negative, positive. 0. 0, 0, 0. 0, negative. And positive 10. Positive, positive, positive. So this is what I expect. Positive derivative, function must be increasing. Negative derivative, the function must be decreasing. Positive derivative, the function must be increasing. What type of point is negative 3, comma 54? And what type of point is 3, comma negative 54? The first one.
Max.
Very good. And of course, this one is a min. Thank you very much. Very good. Finally, we are ready to look at the second derivative. This is the first derivative. The second derivative is 6x. The same procedure. 6x equals 0 means x equals 0. I put it where it belongs. Careful, I have to put it where it belongs. Under that 0, I have 0 for the second derivative. I have to study the sign, left and right. If there is no sign change, there is no inflection point. I also have to determine the value at 0, which is 0. Okay, now, when I plug in a number to the left of 0, like negative 3, I get negative. When I plug in the second derivative a number to the right of 0, I get positive. When the second derivative is positive, the function is concave upward. When the second derivative is negative, the function is concave downward. I put my sign in here. Can anyone tell us what type of point is 0, 0? keeping this in mind. There is a sign change for the second derivative. What type of point is 0, 0? Cannot be relative max-min. This is only characteristic to the first derivative. For the second derivative, we can only say an IP, inflection point. The second derivative is 0 or undefined, so it's 0, and it changes sign from concave downward to concave upward. 0, 0 is the inflection point.